This is Physics 241 Lab. We're going to do Laboratory 2 today. And our lab today has two parts. First part of it is we're going to use our computer program to further explore the concepts of distance, velocity, acceleration, and time. And then the second part of the lab, we're going to use our computer program to measure the acceleration due to gravity, 9.8 meters per second squared. In our first part of our lab, we're going to look at two scenarios. One will be a weight on a spring, and we're going to watch the spring go up and down motion. And we're also going to look at a pendulum. And here we're going to look at motion that goes back and forth. And we're going to use our motion detector to measure these distances, up and down and back and forth. And what the motion detector will be measuring is the distance related to time. It's going to relate how far up and down this goes, how long it takes, how far this swings and swings back, and how long it takes. Knowing the distance and the time, change in distance and change of time, will give us the change in velocity. And knowing the change in velocity and the change in time, we'll also be able to get the change in acceleration. So we'll be able to measure the D and T and determine the V and A. We're going to do this on the computer, and we're going to get graphs of the back and forth motion of both of these setups. And we're going to have two sets of graphs. One's for the pendulum, one's for the weight. The graphs will be on top of each other. It'll be a change in distance over change in time, and a change in velocity over change in time. And the upper graph will be the velocity graph. The lower graph will be the acceleration graph. And we'll be able to compare the graphs of velocity to the graphs of acceleration on a back and forth motion on a pendulum. And we'll do the exact same thing on the back and forth motion of a weight bobbing on a spring. So the data for this first lab is going to be these two graphs. The second part of our lab will be using what we call a picket fence. A picket fence is a long acrylic strip that is black and white, checked, sort of like a picket fence. And we're going to use a photo gate to measure acceleration. The photo gate looks something like this. It's like a fork, and it has sensors at the ends. And we're going to drop the picket fence through the photo gate. And what the photo gate is going to measure is this little distance, this black distance and this white distance, and how long it takes to go from this distance to this distance. And that distance over time is a measure d over t. So by going through this process, hooking it up to a computer, we're going to be able to generate graphs of velocity and acceleration. So again, the computer should generate a graph that shows the change in distance and the change of time looking something like this, and then the change of velocity with respect to time, which is the acceleration, and it should look something like that, a straight line upward. And if we use the linear fit function of our computer program, that linear fit will tell us the slope of this line. And the slope of that line, that acceleration line, the slope of delta V, delta t, is going to be the acceleration of gravity. And if it's done properly, we should get a number of about 9.8 meters per second squared. We're going to do this dropping of the picket fence through the photo gate 6 times to make sure we get and can replicate that number.
Okay.
How long is it?